Okay. Now, we're going to hit level 3 and level 4, and I know some of you are in the middle of level 4. So if there's something that we're going over and you're like...
Wait for 2 levels away from level 4.
Oh, then you're going to be okay.
I'm 2 levels away from completing level 4.
Then we're good. Now, we do have to go back to level 2, but I still see it happening in level 3, and it's that crazy locked green vortex. Every once in a while when I walk by, all of a sudden I see that somebody has a locked vortex on one side of their screen. I want to show you what that looks like mathematically. Okay? And it's nothing bad. You can get yourself out of it, just like in Dragonbox. You can get yourself out of the locked green vortex and still solve that frame. You can do the same thing in math. Let's go ahead and put down our first 2-step equation. 2n plus 5 equals 17. Now, when we get the locked green vortex, this is what happened. Well, first of all, let me rephrase that. What is our number one goal when we're solving even a 2-step equation? What do we want to do? We want to get what by itself?
The Dragonbox.
The Dragonbox, or in this case, the n. That is our overall goal, whatever we have to do to get n by itself. Sometimes we get a little confused, and this is what would happen to get a locked green vortex. I'm going to take away 17 from this side. If I take away 17 from this side, I have to take away 17 from this side. Why did I match the 17 up with the 5? Any ideas?
Because whatever you do to the other side, you have to do to the...
And can I take away 17 from 5?
No.
Yeah.
Yeah, they're both numbers. It's like 5 minus 17. Wyatt?
But on Dragonbox, you'd have to put the negative 17 under the 2n.
Nope. Nope. This is like when we clicked it on the bottom. Let's see if I have a picture here. When we click it on the bottom and it changes colors. What happened to my locked green vortex? Here, let me show you. I do. I take screenshots. So like if I click this -3, if I click it down there, what's going to happen to it? It's going to turn to a positive. If I bring a positive up here, then I just have to bring a positive to this side. I don't have to put it underneath everything.
And then you can unlock it.
And then I can get that done.
No, then you can unlock the vortex.
Well, that one I can, yes. So let's look to see what happens here. So what I did was I took 17 minus 17. Well, that's 0. That's my locked vortex. I literally just got rid of everything off of one side of the equation. I moved it all over to the other side. There is absolutely nothing here. Now, just to show you that this is the locked vortex, I'm going to put like these little earmuff things on my 0. Because it's not bad. You're not like, you haven't dug yourself into a hole and you can't get out of it. You're going to still be able to solve this. But we're just going to need to do one more step now to be able to get this solvable. 5 minus 17 is, if I have 5 and I want to spend 17, -12. Okay. So basically what I have is on this side, I have 2 times the Dragonbox. I've got a -12, and I have absolutely nothing. I've got this locked vortex that's screaming at me, you just took everything away from this side of the equation. Our goal is to get the Dragonbox by itself. What do I have to do with this -12?
Cancel.
Make another negative. I mean, yeah, no.
If it's a -12, how do I cancel that?
Positive.
A positive. So now I'm going to put a +12, and what I do to one side, I'm going to do to the other. And now I'm moving something over to the other side, which means I'm going to unlock that vortex. That vortex is going to be able to be clicked and be gone. So now I have 12 plus 0, which really is 12. I don't need to put plus 0. I'm going to click on it. It's going to go away. And look at how easy I now have it. 2 times n equals 12.
Yeah, we all know it's 6.
We all know it's 6. Mathematically, how do we know it's 6? What do we have to do?
Because 2 times 6 equals 4.
So how do I solve and work backwards? What if I can't see this? What would I do?
Okay.
Divide it by 2.
Divide by 2.
This is 2 times n, so I'm going to divide by 2, and n equals 6. Okay? Now, technically, probably what I should have done, let's just rewrite it over here on the side. 2n, oh, am I not on? 2n plus 5 equals 17. Instead of trying to get that 17 away, what really should I have done?
5.
The 5. I'm trying to get the n by itself, so I want to get rid of everything else, and then I want to work with the n. So I probably should just have subtracted the 5. What'd I do to one side? Got to do to the other. Poof, he's gone. I've got 2n equals 12. I get the same thing. And notice how much less space I'm going to have to use. Now I'm dividing by 2, n equals 6. I was able to solve that in 2 steps, whereas here I had to use 3. It doesn't matter how many steps you have to use. If you want to be very efficient, you just start working on, let's get rid of everything, and then deal with the Dragonbox. Okay, basically the algebraic rule is just to remember rule number 1. Get n by itself. Or I should have put isolate the variable. That's the whole goal. That's what drives every single problem. Get the variable by itself. Yes?
How come we didn't turn 12 into negative? Or are we just subtracting?
It never was a negative. Over here, it was a negative because 5 minus 17. But then to get rid of that negative 12, I had to add 12.
Yeah, but on the negative, 17,
Minus 5?
so that's not negative.
That's not a negative. That means I have $17. I'm going to spend 5. I will still have 12. Okay, we've talked about that negative variable. Let's actually look at what's happening there. This one won't take us very long. This rule is pretty easy. Oh, but in Dragonbox, I forgot. You get this power that you get to move something to the other side, and what happens?
It's level 4.
And make it the opposite.
Yeah! If it's on the right side and I take a blue fish and I move it to the left side, it's now a purple blackfish. That's kind of a cool property. So,
Can you slide your paper?
oh, sorry, thank you. Move to the other side, changes color. Okay, so in the game, if I take something green and I move it over to the other side, it's now purple and black. If I take something purple and black and I move it to the other side, now it's the blue or the green or whatever. Now it's got the color again. Okay, let's look at mathematically what happens. Let's say we have a negative x equals a positive 25. Now we already know from last week, we don't want a negative Dragonbox. We want the nice little pretty red Dragonbox. So what are we going to do? We're going to drag him to this side, right? And then what are we going to do with the 25? We're going to drag him over to this side. And if you haven't got to this power yet, who has got to this power that can tell me what's going to happen if I just switch them around?
They change. The
So-
25 will be negative and the x will be positive.
Yeah, it's kind of a cool power. If you need to get to the opposite, you just drag it to the other side, and it'll actually switch the colors.
It'll
My-
take like 2 seconds. Though.
It'll be what?
It'll take like 2 seconds to do that.
Yeah, I know, it's very easy. You don't have to click on the bottom, and you don't have to, you know, get it to the opposite. You can just literally drag it over. What is happening is this. If we have a negative x equals 25, now we already know, what is that number in front of the x? 1. Okay? Now, if I wanted to get just x by itself, this is a negative 1 times x. What would I do? Well, I could just move it, but mathematically, what would I do to get If it's a negative 1 times x, I'm timesing by a negative 1. What's the opposite of multiplying by a negative 1? Dividing. So I could divide by a negative 1 on one side. If I do that, what do I have to do on the other side? Same thing. Divide by a negative 1. Now a negative 1 divided by a negative 1 equals a positive 1. Looky there. It's now a positive x. What is 25 divided by a negative 1?
Sorry. Did that email look okay? Did you have a chance? Okay.
That would be a negative 25. So that's exactly what the game is showing you. But this is mathematically why it works. Why I can drag that x, negative x over to the other side and it becomes positive. Because I'm basically just dividing or multiplying by a negative 1. And what I do to one side, I have to do to the other. Okay? The game makes it super easy. I just switch sides and I'm there. Basically, it's still the property of equality. What I do to one side, I got to do to the other. If you're going to move one thing over to the other side, you better move the other thing over to make sure it's going to work. What time is it? This is a review from last week. Let's just go through this one real quick. Put same color, shape. So if I have a blue fish on the bottom, oh, sorry. If I have a blue fish on the bottom, and if I put the same color shape on top, what happens? I think I have a picture for this. Okay, so if I have, so here I have a red dragon on the bottom, and I went and I put a red dragon on top. Why did I do that? What's my purpose?
Because then you can make the dragon boxes on the top.
And make it a little dot.
Yeah, you make the 1, and then you can just
Drag this one up there, it becomes the 1. Do I really need the 1? Drag the 1 over, and I've got my dragon box by itself. So if I have something sitting down below the dragon box, if I drag it on top, it will get rid of what was on the bottom. So put same color shape on top to get rid of the bottom. Now, obviously, if I put something on top on one side, I got to go do that to all the other ones, and it, you know.
Wait, but on Dragonbox, if it's a 1, it's different. It's Dragonbox.
Well, if I put this on top, I'll drag this one up here. It will turn into that 1 dot, and then I can put the 1 dot right into the dragon box, and then it's just the dragon box.
Yeah, but like if you get further, it just turns into algebra and then more animals.
Oh, yeah, you definitely are going to start to see what we're doing here. You will start to see this more in the game, which is good. They're kind of weaning you from the cute little pictures as you get better and better and better. Okay, let's look at something here. We've got x over 10 equals, let's say, 25. So I'm dividing my unknown, my dragon box, by 10. Well, how do I undo?
2,500.
How do I undo dividing by 10?
Put a 10 on top.
Put a 10 on the top, which means I'm going to be multiplying by 10. I stick them in parentheses. I'm trying to make, my notation as easy as possible. If I multiply by 10 on one side, I have to do this to the other.
Then the 10s match up and make 1.
10s match up, make a 1. I drag it over to the x. I've got x. And then I have 25 times 10, which is actually 250.
Whoa.
And again, this is the property of equality. You are going to think this so many times as you solve. What I do to one side, I have to do to the other. And hopefully it just becomes automatic, that you don't even need to think that anymore. Okay, so where are we actually headed? This was a lot of review from 2 and 3. Go ahead and flip your page. I think we're still in 3, to be honest. But sometimes we have to combine like terms. had this die of 2. They just simplify the problem so you don't have look like Chad. We have plus 2 equals 6. So do I really have to have them separated? Plus 3 plus 2. I might as well put them together and get plus 5. Now I'm going to write everything else down exactly how it was, and already it looks much easier. Now, what would be the next thing you would do?
You would have the
3.
Well, but the 3 is kind of attached to the Dragonbox, isn't it? Would this be pretty easy to get rid of?
yeah.
We're adding 5, so what would I do to get rid of it? I'm going to subtract 5, and what I do to one side, I've got to do to the other. Well, that's pretty easy. That's going to give me a swirling green vortex, so that's good. He's gone. And 6 minus 5, that's just 1. So I have a number divided by 3 equals 1. Now, I know some of you can see the answer, but mathematically, what would I do now to get the answer?
Put the 3, put a 3 on top.
Put a 3 on top, which was the rule we just learned. We had a 3 that we were dividing by. It was on the bottom. So by putting it on the top, I'm multiplying. What I do to one side, got to do the other. I just heard Gage say, okay, 3 divided by 3. 1. Don't need to put it. I'm just going to put in. And 1 times 3 is 3. There you go. Nice. What happens, I may have seen some of you with a problem like this. What happens if we have n plus 5 plus n equals 8?
What?
I have n plus 5 plus n
0.5
equals
is your answer.
8. Now, how many dragon boxes do I have?
2.
Can I put 2 dragon boxes together? I don't know if you can in the game, but you can in math.
Yeah.
What is n plus n?
1 in. Well,
It's actually 2n. Well, if you think about it, a dragon box and a dragon box is really 2 dragon boxes, right? Okay? We might as well put them together. Because now look, now I've got 2n plus 5 equals 8. Okay, what did you just say? Minus 5, there you go. And what I do to one side, I got to do to the other. Notice I'm always getting rid of what is not attached to the dragon box. Whatever is just kind of out there, I'm getting rid of all of that stuff first. So 5 minus 5, he's out. 8 minus 5 is
3.
3. Now I've got 2 dragon boxes equaling 3.
2 divided by 3.
No, not 2 divided by 3.
Or not 2.
What am I? It's 2 times n, so I'm going to divide by 2.
Yeah.
Okay, so 2 divided by 2 is 1. That leaves me with n. And 3 divided by 2 is 1.5. Each dragon box got 1.5, whatever this thing was. Okay, I want to end with one more problem, a little bit tougher one, so you have this in your notes. Now remember, if you're working on your homework and you get stuck, refer back to your notes. I am purposely picking problems that will help you go through the process, but you may have to read through each line and be like, now what was she doing again? What am I supposed to do? How would this look like in the Dragonbox game? So that you can apply it to the problem you're trying to do. This last rule is always undo addition or subtraction before dealing with the Dragonbox. Save him till the end. Whatever is attached to the Dragonbox is with the Dragonbox. Get rid of everything else that you possibly can get rid of and then deal with the Dragonbox. Let's look at a problem. Now I'm purposely going to put a fraction in here because I know sometimes we get a little eked out about fractions, and I just want to show you how easy they really are to work with. N over 2 plus a fourth equals 6. Now I'm curious. How would you go about solving this in the Dragonbox game?
I would put 2 on top.
You would put 2 on top? If I put 2 on top here, what am I going to have to do? I'd have to do it there. And what about here? I'd have to do that there. Do you know what you're doing when you do that? You're basically doubling everything here. It's fine to do that. Mathematically, this is what it would look like, what Wade just said. He's going to put a 2 on top of everything. He's going to multiply everything by 2. So what we can do is we can just put it in parentheses and say, hey, we're going to double the entire thing. So that means I'm going to put a 2 on top here. So that's 2n over 2. What is 1 times 2?
1 or 2.
2. So there's going to be a 2 over 4. And 6 times 2 is 12. Now some of you might be looking at that going, well, did that simplify something?
Yeah.
Yeah, because we've got the 2 over 2, it's done. So I now have n plus, hey, let's simplify 2 over 4. What's 2 over 4?
1.5.
It's a half, okay? Okay, this will be so much easier. Yeah, let's simplify that to a half. So we have some number plus a half is equal to 12. Now when I say it like that, some of you are like, well, yeah, I know the answer.
Yeah.
Mathematically, what would we have to do to find the answer? How would we need to get the Dragonbox by itself? So I need to get him by himself, so what do I have to do? I'm going to have to subtract a half. And if I subtract a half from one side, I have to do this to the other. So that's going to be gone. N equals 11 and a half. Because 12 minus a half, it's not half of 12. Now, real quick, I want to show you just another way to do this. Just follow along. Let's rewrite it again. N divided by 2 plus a fourth equals 6. Wade wanted to double everything in there, which is fine. It's a legal move. A lot of people do it. Okay? Let me show you another way. You could have just taken away a fourth.
Yeah, that's the other way.
Okay? 1/4 minus a fourth. Boom, he's gone. What is 6 minus a fourth? 5 3/4, right? So nothing too terribly hard here. I have n divided by 2 is 5 3/4. Now we can go and think about Wade's method. There's a divide by 2. The 2's on the bottom, so what do I have to do? Multiply by 2, put it on top, and I'm going to double multiply by 2 this 5 3/4. What is 2 divided by 2? Actually, it's 1. Okay. Now, if I were going to double 5 3/4 in my head, this is what I would do. 5 doubled is really easy. What is 5 doubled? 10. I'm going to put down 10. Now, I have 3/4 and another 3/4. I'm going to double the 3/4. So it's 3/4 and 3/4, which is really 6/4. Now, would I see a fraction like that? 10 and 6/4? What is 6/4? 3 over
2.
3 over 2. What is 3 over 2? 3 divided by 2. 1 1/2. So this is actually more than 1. So if it's 1 1/2, I already have 10, and then I need to put a 1 1/2 with it. So my answer is really 11 1/2. Is that what I got? So 2 ways there that you can do that. You can either think about it how Wade did. He was going to get the Dragonbox alone first. He had to remember he had to multiply everything by 2. Or you can get rid of whatever's hanging out and then finish up solving that. Okay. 4, oh boy, I tell you what. When I said you would probably have homework, you probably are going to have homework. But I've got a page of 2-step equations. Now, I will tell you this. I just glanced at the problems. You may need to look back at all of your notes. There's going to be hints on all of your notes. So keep your notes together. The good news for you is it's due on Thursday. We will grade these after we get back from the play.